Hello and welcome. We will get started shortly with the 10th episode in TechSite's webinar series, Pioneers in Digital Diagnostics. We'll give a moment for others to join. Welcome. Thank you, everyone. It's wonderful to have you on today's webinar entitled Transforming Gram Stain Analysis with AI, a case study from Mayo Clinic. And this is our 10th episode from TechSite in the Pioneers in Digital Diagnostics webinar series. We are delighted today to welcome Angel Strasburg from Mayo Clinic, who I'll introduce more fully shortly. Angel, it's wonderful to have you.
Thanks, Jacob.
As I walk you through the agenda, I want everyone to know that there will probably be lots of questions and practical implications that will be sparked by some of what Angel presents today. So please enter your comments, your questions into the chat at any time. We do have a team moderating those, and we have time allotted at the end to answer your questions. And for any that we don't get to, you will get a custom follow-up from TechSite. So I'll spend a moment to help our viewers understand TechSite. Then we'll turn the time to Angel and learn about Mayo Clinic's bacteriology team, its experience with implementing AI for microscopy, how that's impacted patients and the laboratory staff and lab technologists, including their own feedback. This will be interesting to hear what the technologists have thought. Mayo has many of them. And then we'll conclude, of course, with Q&A. So first, just a bit about TechSite. TechSite is the clinical and anatomic pathology AI platform. We have built an AI and workflow software platform that helps automate and digitize microscopy tasks across laboratories in a major way on the human side of our medical platform with anatomic and clinical pathology, and then also in the veterinary space with our distribution partner called Zoetis, formerly known as Pfizer Animal Health. And then in environmental, we have solutions for home inspectors and industrial hygienists who are doing mold inspections. So it's all part of one platform. We've been growing consistently over the last decade. We were originally a technology transfer out of the University of Utah and ARUP laboratories. And now we've had over 4 million diagnostic tests performed where laboratorians and veterinarians use the platform to make some final decisions on the health of their patients and pets, as well as environmental type spaces. We are a fully remote company and with headquarters in Europe as well as in Utah, the United States. Our mission in building this platform is to positively impact the health of humans, animals, and the environment through the use of AI. And we really intend to become the preferred digital pathology and diagnostics platform across each of these areas: human, veterinary, and environmental. When we talk about our platform, it's more than just the AI, the workflow software component, and the ability to integrate end-to-end with an LIS and EHR to host images, to help with data curation, all in a HIPAA compliant, SOC 2 compliant environment. That's all important. So the platform really is only as valuable as it helps the laboratory become more efficient and more accurate in its decision making. And on the right-hand side of that visual, you can get a feel for the AI plus all these other components that make up the TechSite platform. And you'll hear that come to life in Angel's presentation around all the elements that go into automating and digitizing microscopy using AI and workflow software. On the left-hand side, you can see a list of the medical disciplines in which TechSite offers AI and workflow solutions. Today, we'll be focused on our bacteriology solution, but we do have AI and workflow tests across anatomic and clinical pathology sample types, and would welcome any conversation that you and your lab might have interest in having around what it might take to automate and digitize your microscopy. The way we build those models is in collaboration with Mayo Clinic. We are delighted to have this collaboration with Mayo. It enables TechSite to have access to Mayo's data or samples and slides, as well as to Mayo's expertise, Angel being one of them, where using Mayo's input, we can make sure we're building a product that actually is fit for purpose, that enables clinical sensitivity and specificity in a production environment to help improve patient care and laboratory staff experiences. Okay, let me introduce Angel and turn the time to her. It's been a delight to work with you, Angel, the last couple of years, and we're excited to have you share with the wider world your experience in using TechSite and transitioning your gram stains to digital and AI. Angel has been with Mayo Clinic several years now. She does have oversight as technical specialist too over the general culture work, digital pathology, and the implementation of the Copan WASP automation in Mayo Clinic's bacteriology lab. She received her medical laboratory science degree from Winona State University there in Minnesota. And since then, she worked as a technologist in Mayo Clinic's hospital clinic laboratory. And then she transitioned to the bacteriology laboratory. And then in 2018, she was promoted to technical specialist 1 with oversight of the general culture workup and bacteriology's rapid testing. And then a couple of years ago, Angel was promoted to technical specialist 2 with the additional oversight of digital pathology and laboratory automation. So without further ado, we welcome Angel Strasburg. Thank you so much.
Thanks, Jacob. As Jacob said, my name is Angel Strasburg, and I am the technical specialist in the bacteriology lab at Mayo Clinic in Rochester. And today, like Jacob said, I will be talking to you about what it was like bringing digital pathology and AI into our lab space for gram stains. So the Mayo Clinic bacteriology team, we are a 24/7 lab, and we have gram stains reporting on all shifts. We have greater than 50 technologists in our lab. A handful of those are going to be on our evening shift. 2 of them are rotating between our overnight shift, and then the rest of them are on our day shift. And on each of these shifts, only 1 technologist is assigned to gram stain reporting for that shift, while the rest of the technologists that are working are handling all other culture work that's going on at that time. Our technologists have been through quite a lot this past year, everything from workflow to processing to construction and anything in between. They have dealt with it all and dealt with it very, very gracefully. While we are bringing on digital pathology, we are also implementing the Copan WASP automation system. And here's a couple pictures of kind of what that's looking like for our lab. On the right, you'll see what it used to be like in the lab. There used to be these bench tops with wide open spaces for manual workup. And on the left, you'll see a little bit of the very controlled construction chaos, but just a glimpse of that's part of the lab that our technologists no longer had access to at that time. So we're no longer having as much room to spread out as we used to have, kind of like in the bottom left-hand corner, some narrow hallways at times. After that, the construction was completed and we have these wide open spaces, another mind shift change for our technologists. Think we have all this room and what are we possibly going to do with it? Well, then here comes our Copan WASP instrumentation. And the pictures above, obviously it's not in a very steady state. There's boxes, a little bit of wiring out there, but it's a very different mindset for our technologists. No longer is it just these bench tops where you're going to put your culture plates. They're seeing automation, they're seeing instrumentation, and especially in bacteriology and let alone microbiology, this is a very new look for a lot of laboratories. So our workload, what does it look like for us? We have about 80 slides a day. The majority of those slides are going to be on our evening shift. And then it does say here we have a 30% positivity rate. I would agree we have a 30% positivity rate, but the thing is that that means that we have a 70% negative rate. And that is the thing that really stood out to us, where the majority of our specimens and slides that are coming through, we're not seeing microorganisms. And we thought that was a big room for improvement with AI of could we send those out potentially quicker than we are. The pre-digital pathology requirements, before we even get into AI and resulting, there's so much work that needs to be done to get the specimen to where it needs to be. The specimens are processed, they're aliquoted, the tissues are munched, they're centrifuged. Whatever needs to happen to that specimen before all this happens, that's when the smears are created, put in the biological safety cabinet to air dry, and then they are methanol fixed. Finally, we apply the gram stain to the slide. The cover slips, because of right now, every scanner needs a cover slip, and we let those dry. And finally, you put them on the scanner. All of that to say that just reporting and the AI is just such a small part of it that there's so much work up front that goes into making these slides. And with that work, it's all about optimization. When you're talking about manual reading, you look at the two pictures of the slides on the right-hand side. The top slide, that's not something I want to review manually. It's thick, it's junky. Am I going to be able to differentiate organisms from background? It's kind of hard to say. Whereas the bottom is a more clean slide that's what I want to look at. I feel much more confident reporting from that slide than I do the top slide. Well, when you bring in digital images and AI, that's going to be extrapolated. Whatever you're putting into the system, your results are only going to be as good as the slides that are being scanned. So our first step was really to optimize our slide prep. To do this, we did several things. The first was that we adjusted the volume that we're putting on the slide. We used to do 1 pipette drop, then we moved to a 10 microliter loop. After that, we changed the slide type. Before we put them on just plain, simple glass slides, and now they're going on glass slides, brought to you by Apicore, and then their fiducial markers are pre-printed on that slide, and that's what you're seeing on the right-hand images, those 5 black circles on each slide. That's going to give your scanner something to focus on. It's not so hard to focus on your thick body fluids or your respiratory samples, but when you get into your sterile biopsies, your tissues, your swabs, that's where it's going to be more difficult for that scanner to pick up what to focus on. By putting those fiducial markers on there, you're always giving your scanner something consistent so it can get a good focus and a good image for you. After that, we changed from heat fixation to methanol fixation. Heat fixation, it can distort your microorganisms, and it will also kind of rupture your white blood cells. It will give you a less clean background material than your methanol fixation. We also implemented an automated stainer. Anyone who works in bacteriology knows that there's a very strict time period of what stain you're supposed to apply to the slide and for how long you're supposed to leave it on there. But then anyone who works in bacteriology also knows that that's going to vary from technologist, just slightly, but it will make an impact. I made it colorize 2 seconds longer than my colleague does, but I have grown accustomed to my stain and how that looks. The scanner, if we're going to start using AI, cannot account for that from tech to tech variability. We also implemented an automatic cover slipper. Granted, it's only 80 slides a day, but nobody is going to want to manually cover slip 80 slides a day. And then the thing that really blew all of our minds, I believe, was the labels. Nobody thought for a second that labels would be such a big deal. We take for granted for manual scans that your labels can hang off the side a little bit, or there can be a little bit of stickiness to it, no big deal. As soon as you start playing around with automation, your grippers are going to jam, your slides are going to fall into your scanner. It's going to be a fiasco. You need those labels properly seated on your slide. And also the label format. We did change from a 1D barcode to a 2D barcode. Once again, you can say that's not a big deal, and I would have agreed with you until anyone who ever has formatted a label knows that that is in fact a very huge deal. And on that being said, you can do all of that pre-processing up front. You can change everything you thought you could possibly change in the world, but you still need to be ready to pivot. Initially, we went live with the Hamamatsu S360 scanner, and that's where, like we had talked about before, those fiducial markers, it's going to focus on those fiducial markers, and then we accounted for different Z layers that we wanted scanned based off of that and our specimen type. Well, since we're implementing Copan WASP, we quickly learned that there is one compatible slide type with that system, which of course does not contain fiducial markers. What we had to do is we shift to evaluating the Pramana Spectral HT2 scanner. This no longer needs those fiducial scanners or the fiducial markers. It has the dynamic pixel level Z stacking. And what that does is it will look at a focal point. It focuses on that one point and it adjusts at what Z layer was at the best, and it moves on to your next field. And it has that dynamic experience with your sample. While bringing another scanner in is a big deal, it's validation upon validation, but there's also another aspect of it that you have to you have to think about, and it's your AI model. The Hamamatsu scanner and the Pramana scanner, they do create images of the same slide, but no scans are created equal. Really, there are very minute differences between the two that will impact your model. So you do have to incorporate both images into your model or whatever you're going to end up using and just factor that in. So what does this mean to our lab technologists? The thing that they're going to talk to you most about is going to be the time savings. Noticeably, it did shorten our time to read slides, and that's where we talked about those negative slides. That is what had the most impact, is getting those negative slides out quicker. Areas of interest are displayed for you. You no longer have to search around the entire slide trying to find objects that interest you. Now your gram-positive cocces are all laid out for you. Your white blood cells, the images are laid out for you. And you simply have to scroll through the web browser and see, do I agree? Do I disagree? Our respiratory slides, when they were manual, they took us approximately 1 minute. But then when we brought in AI-assisted review, we brought that down to 30 seconds, so about half the time. But the big thing was our non-respiratory smears. Non-respiratory smears manually, they used to take us about 2.5 minutes. And now with AI, it's 1 minute. And that's where you're going to see that negative slide impact of how quickly can you get those negative slides out with AI and really focus on the positive slides and use your expertise in those situations. The ergonomic benefits of not having to hunch over a microscope all day and look through the light source and get those headaches that all the technologists dealing with microscopes know full well about. And reporting can be done from anywhere. It is true that you're still going to have somebody there to do the staining and the cover slipping and putting it on the scanner. But when it gets to that reporting, since it is a web-based application, that can essentially be done from anywhere. And whether you want to consult with one of your colleagues on a more difficult smear, or per your procedure, you have to have your positives reviewed by a second technologist, that's now going to create minimal interruption to their workflow as well. It can be as simple as sending a quick message, or if your style is shouting across the lab, so be it. But they don't have to get up from their workstation. They can pull it up where they're at, and then they can just assist you from the web app. Our education specialists greatly appreciate how images are saved and easily accessible for their many educational events. They don't have to sift through their many boxes of slides, hoarding those, which will essentially degrade in a couple of years. And then they're left trying to find those specimens again and take pictures. These images are saved and readily available for them for many years to come. And like I talked about before, the future state with lab automation. The aim is going to be to view digitally both our gram stain and our culture side by side. And this will give our technologists the whole picture, hopefully at the beginning culture workup, where it's really going to make the greatest impact. And then more importantly, what does this mean for our patients and how does it help them? We were very excited about the results that our AI validation showed us. Additional organisms were reported in greater than 10% of specimens, and this allowed for faster and more targeted antimicrobial therapy approach. You'll see an example there of a yeast. So AI presented us with those 6 images that it found on the entire slide. This was part of our validation, we initially missed those 6 fields on manual review. And since it's a validation, you have to now go and pinpoint exactly where those are on your manual slide and confirm that, in fact, AI is correct. In this slide in particular, while looking at it, we're instantly thrown off that it's predominantly gram-negative bacillus and gram-positive cocci. And that's what your mind is drawn to, and that's what you see. And you're not really going to emphasize the scarce yeast on the slide and scan it as thoroughly as AI is going to. So AI in that situation was able to not necessarily ignore the gram-negative bacillus and pos cocci, but put that aside for a sec and finish scanning the entire slide that we may not have successfully done manually. And there is a note that 2+ yeast did end up growing on that culture. And we talk a lot about organisms and additional organisms that are reported and the benefit of that, but it's also important to note that there was increased sensitivity in the detection of white blood cells. And this is important for our physicians to assess the sample quality and determine if there's an active immune response occurring. Not everything is without its challenges, however. We did notice the biggest thing the hurdle that we had to overcome was the fact that some of our technologists have been doing this for 20+ years. They were trained using a microscope. They've done it day in, day out. They've perfected using a microscope. And then throwing digital images at them, we knew that that would require a lot of education. But what we didn't count on is the emphasis that we should have placed on was the practice and the repetition. And that was where we found our technologists were gaining the most confidence and comfort with the system. And you can educate them and have all the events, but what you really need is that confidence and that repetition, while, as you can imagine, with greater than 50 technologists is difficult to obtain, it is very important, and it showed in their quality of work and their comfort and their joy with their work. The turnaround time, we were talking about how the reporting time was decreased. That is true, but then our processing time, our pre-processing time was increased. And that really emphasized that we are trying to get that optimal slide prep. And while that is important to do manually, digitally, it is extremely important. But the biggest part of that pre-processing that is a holdup is that cover slip and waiting for that cover slip to dry before putting it on the scanner. And as many people probably understand, that patience is not everybody's strong suit. So who's going to stop me if this slide is not completely dry and the glue's just a little sticky? The scanner should be okay. So what we've been seeing is that sometimes we'll push those boundaries and we will put those on the scanner. Well, after that, then you now have glue on your objective of your scanner. Anyone who has to then chisel that glue off the objective is not going to be extremely happy. So this is something that we're looking at with Permana, of maybe hoping to eliminate this in the future. But that's going to take some time and quite a bit of developmental work until that is set in stone. And then importantly is our staff feedback. Our technical specialists in bacteriology have put all the effort in the world into this, and we have delivered our staff the best product, but it's not going to get very far if you don't get their feedback and their buy-in to the situation. So after talking to our techs about how they felt about digital pathology and how they think it's going and what they want to change, a lot of them admitted right away to being skeptical about it. And rightfully so, I understand that. We're microbiologists. We got in the field to get our hands dirty. We didn't get in the field to push the buttons. So when we talked about how they felt about having the digital image instead of the scope, many were pleasantly surprised that they didn't feel like they were missing out on anything with their job anymore. They just thought it was an improvement. And then not only that, but they were relying on the efficiency gains of the quicker review time and the ease of use of the system. And when it comes down to it, our technologists, they want to do things efficiently. They want to do things accurately. They don't want to put in overtime to have to look at these gram stain slides. They want to go home and have a good work-life balance. So those quick review times were very positively received. And I didn't need to be pulling reports to tell our technologists that we are detecting more organisms with AI than we would have seen manually. They're feeling it. They're seeing the AI call out this one cluster of staph or this one chain of strep that they wouldn't have typically seen. The newer technologists and our overnight techs who don't have someone there on the shift have pointed out that it's like having another technologist there that you can get ideas off of and bounce stuff back, and just helps point you in the right direction. And especially knowing how the field is these days with those new technologists, it's an expertise. Gram stains are tricky. Gram stains are hard. Having anything to help point them or aid them in the right direction is going to be a huge benefit to them. We talked about weeding out the negative slides and how quickly and efficiently our techs are able to read those slides now. And it eliminates much of the subjectivity of gram stain reporting that was present for manual review. I can look through a slide and counting up the gram-positive cocci in my head, and I'm averaging the fields as I go, and I can come up with an answer of few. Well, my counterpart might look at 50 different fields, average it with slightly different math, and come up with moderate. And that's just not the clear-cut answer that technologists and scientists are looking for. So AI does those counts. There's real math, there's numbers behind it, and it just eliminates some of that subjectivity. So as you see, our staff are very pleasantly, they're enjoying AI. They're embracing the change of the digital workflow. And their feedback and their positivity through all of the change has really been the key to its success. So what we're hoping to see here for the future for our COFAN system with digital imaging is we're hoping, learning from this, that we'll have that repetition, we'll have that honest feedback with each other, and they'll be just as pleasantly surprised with digital imaging as they are with the gram stain imaging. So I guess that's where we're at for questions.
Awesome. Thanks so much, Angel Strasburg. It's great to have you. We have had many, many questions. So we'll jump right in. I know we won't get to them all, but we will follow up with you privately. Let's see. I believe this one might have been an answer, but why don't you just verify what automated gram stainer are you using at Mayo, Angel?
We're using the Midas stainer.
Great. What type of specimens have you validated in your lab? Respiratory only or CSF, blood, sterile sites? In the Mayo validation study, what was the overall agreement between the TechSite AI and the manual reading? I get there's a lot there. You want to maybe two pieces? What samples, what specimens have you validated so far?
What we validated so far, we're in the process of validating more currently, but we have validated smear types. So anything from synovial fluid, respiratory, tissues, biopsies, swabs, synovial fluid, body fluids, kind of you name it in that situation. What we're still working on and developing, because we did have to have that scanner change, so that did take a little bit of time and energy to implement that. But we're doing anything that is cytospun. So our not synovial fluid, our CSF samples, that's our bronch lavages, those ones in particular, that's what's still coming. As far as agreement numbers, that unfortunately I don't know off the top of my head. But I mean, like we had said, there's additional morphologies that were pointed out with AI, but it was an extremely high agreement and a lot of times in favor of AI.
Thanks, Angel. Vincent asked, are you doing concentration techniques? How is this factored into the computations?
We are not doing concentration techniques. I think our parasitology lab is working more with concentrations, but the most that we're doing is cytospinning. And then when that happens, we report presence or absence.
Jacqueline asked, have you come across any issues with artifacts?
We have, in the sense of more so with our pre-processing though, where does the stain time need to be adjusted, the decolorizer, to get rid of that precipitate on the slide, or are our stains honestly just being too thick? Should they be smeared thinner? So it's a lot of a prep issue in that situation. But when it comes to AI calling out artifact, that we still can see. You're never going to get it perfect, obviously. Like an epoxy, that's going to be difficult to not have every pink dot pointed out. But really, artifact hasn't been a problem when it comes to AI. And we're still having our technologists review it. It's still up to them to make the final call. And that's where, if there are any artifacts in there, your technologist is very easy to just screen through them and say, nope, I disagree, and change the result.
Because the technologist is finding what the AI has boxed and identified, as well as semi-quantitated, but they get the final call. So
exactly.
Okay. Julianne asked, what type of quality control do you use?
Quality control, every day we run 2 slides through the scanner. It's going to be kind of a mix of, is a scanner properly calibrated? Are we seeing, did someone slip through a wet slide and now there's glue on the objective? And that's going to show the banding, and just make sure that your images are up to par. It's going to show, is it blurry or not? And then from the AI perspective, we do run through various organisms, and then make sure that the semi-quantitative report is within range for those counts.
Karen asked, is it validated for blood culture? So I'll take that one. TechSite and Mayo have co-developed this solution. This is our first co-release product. We have many others that we're actively developing across departments, including bacteriology. Blood culture was not in scope in this initial version. It is a sample type that is being added in the next several months, just like urine gram stains as well as vaginal smears. So those are additional sample types still being co-developed, not ready for validation yet. Great question. Linda asked, do you use primarily e-swabs? And if so, do you notice fewer white blood cells on the smears?
If you check back in a few months, I might be able to answer that one. Now that we're moving a lot of things to COPAN, we are going to have to switch to a lot of e-swabs. But right now, that's not really our primary specimen collection container. But I am very interested to see those results as well.
Elizabeth asked, what was the automated cover slipper? What are you using?
The Leica.
Okay. And then Rebecca asked, what features of TechSite, what was TechSite doing in the platform that helped those technologists get over the skepticism?
Oh my goodness. Okay, so many things. So there's just the usability of the system. That in general, having things nicely laid out the way that TechSite does gave our technologists just that ease of use that you're looking forward to and that you need from a system to help bring you what you need to get your job done in a timely manner. But with TechSite, it was more than just their software, and it was more than just their application. It was the communication with the company as well. If there was anything that was ever a pain point in our workflow process or with the system, we would talk about it with them. We would bring it up and come up with solutions on how to fix it. And having the technologists in those conversations was key, where they would give the technical specialists, they would give me the issue that they were seeing, and then I would bring it forward to TechSite, and they would know that I would do that. And as you know, for validations, implementations, this is a common thing. But the thing that is so unique with TechSite is that the results were almost instantaneous. They heard their questions, they heard their problems, and they took it to heart of, we need to get this fixed immediately. And that was kind of the selling point for the technologists of, if there is something that's troubling me with this new digital workflow that I'm uncomfortable with, I can bring it forward and we can get something done about it.
Thanks for sharing. Yeah, I learned some things just from what you commented there. I'd add that TechSite, at our core, we are a software company. That's where we've cut our teeth. We have many founders and developers who have been building software for decades, and that agile approach around being able to respond to the customer needs and build a solution fit for purpose. I'm glad to hear you benefited. That's awesome. We really try to limit these to about a half hour so folks can digest it. Let's do 2 more questions though, Angel, and then we'll handle the rest offline. Really appreciate your generous time today. Robert asked, how was the validation process? How long did it take for Mayo? What did you do to fully validate? There's a lot there.
Yeah, I mean, validations are going to look different everywhere. It was a lot of just running samples through, just like you would for any validation. You're validating that the instrument is giving you the results you need. Are you able to read the scans? And is AI giving you the results that are expected? So it's just a lot of comparing between AI and having a lot and lots of slides be read both digitally and manually, and just crunching the numbers. It does take quite a bit of effort, I will not lie, but it is well worth it.
And lastly, how much training for the technologist was required in order to see the time savings you talked about? How long did it take to see a return on investment?
That's a good question. And kind of like we talked about, there's education and then there's practice. So the educational events, our education specialist did a phenomenal job of pulling in a library of images, and we put a lot of it on our technologists of, if you have some downtime that day, and I know we all laugh at the word downtime, but if you have 2 minutes, just look at a couple slides and get comfortable with, here's the results of what would be reported, and do you see what I'm seeing? Next step of, here's some slides, what would you report? And then look at the results to self-correct. So that was a big undertaking and a lot of effort on her end. And then also there was just the hands-on practice. Getting our technologists, I mean, we have 50 techs, so we would rotate a few core people in there to begin with, have them get comfortable, have them get that repetition. So having that knowledge and that experience, it doesn't go unnoticed. It's just a different way to look at them and feeling more confident in yourself. So our younger technologists took to it right away because they're used to looking at computer screens for absolutely everything they do. Where if you have a technologist that's been there for 50 years, they might need an extra couple days to just get more comfortable with digital. That's where it's going to vary. But as a general rule of thumb, after the first week of being in there, technologists are really getting the hang of it and feeling it.
Yeah, that's a neat part. They can get into the software and just start playing around.
Mm-hmm.
I would mention that TechSite in recent months has added its online user training or its computer-based training. And so that gives a nice baseline in 1 to 2 hours. A technologist on their own independently can walk through that training that's about using software and going digital with also specific gram stain content as well. So that's a nice baseline that then your staff can build upon too. So Angel, you've been very gracious today. Appreciate all the insights and your responses to the Q&A. TechSite will follow up as well as with Mayo if it's something specific to their workflow, and we'll get your questions answered to all you attendees. Again, thank you all for attending this latest episode in Pioneers in Digital Pathology, and thanks again to Angel Strasburg and Mayo Clinic. Have a great day.